Expanding expressions like a plus b to a high power can be hard work. Today we will learn the binomial theorem, a powerful tool that makes this expansion simple. We will first see how the exponents change, then look at how we find the numerical coefficients. The binomial theorem explains how to expand any expression in the form of a plus b raised to the power n. Let us first observe the pattern of the exponents for the terms a and b. Starting with the term a, its exponent begins at n and decreases by 1 in each subsequent step. At the same time, the exponent for the term b starts at 0 and increases by 1 in each subsequent term. The sum of the exponents in every single term of the expansion will always equal n. Now we need to find the numbers, or coefficients, that multiply these terms. These coefficients come from a specific triangle pattern called Pascal's triangle. For n equals 2, the coefficients are 1, 2, and 1. For n equals 3, the coefficients are 1, 3, 3, and 1. These numbers form the numerical part of the general formula for the expansion. Let us combine these rules to see the expansion for a plus b cubed. The full expansion is 1 times a cubed, plus 3 times a squared b, plus 3 times ab squared, plus 1 times b cubed. We can now apply this to a specific problem, expanding 2x minus 1 cubed. In this case, our term a is 2x, our term b is negative 1, and n is 3. We use the coefficients 1, 3, 3, and 1 from the third row of Pascal's triangle. The first term is 1 multiplied by 2x cubed times negative 1 to the power 0, giving 8x cubed. The second term is 3 times 2x squared times negative 1 to the power 1, which is negative 12x squared. The third term is 3 times 2x to the power 1 times negative 1 squared, which simplifies to positive 6x. The final term is 1 times 2x to the power 0 times negative 1 cubed, which simplifies to negative 1. The complete expansion is 8x cubed minus 12x squared plus 6x minus 1. Look back at the expansion and notice how the exponent of the 2x term decreased from 3 to 0. Also confirm that the signs alternate because our b term was negative 1, giving an odd power a negative result. We learned that the binomial theorem organizes complex expansions using two main patterns. The powers of the first term decrease while the powers of the second term increase. The numerical multipliers are the coefficients found in Pascal's triangle for the power n. Use this structure to quickly expand any binomial expression, no matter how large the power n is. Generate your own educational videos for free at eduvids.vercel.app.